Going live. Yes. And we're live. Excellent. Welcome back. Anyway. Wow. Time seems to be flying by pretty quickly. We only have, and I'm going to keep counting them down, 6 class periods until our final exam. I'm so stoked. I don't know. This year has just been a crazy odd year. But anyway, I digress. Did you know that teachers are technically classified as frontline workers? Did you know that? Yeah, I don't think that's fair, but apparently we are. Because you know how like you had the vaccine coming out? Teachers technically right now are eligible to register to get the vaccine. Yeah. Insane. Anyway, back to this. So my goal for today, I want to wrap up a little bit with binomial, but I also want to talk a little bit about geometric. Now, in a moment, I am going to be giving you some last minute information in regards to geometric. I have a PDF that I'm going to be posting into the Google Stream shortly that I'm going to be going over a couple problems with you with. And then to kind of wrap things up, I do have a practice quizzes that I would like to do with you, that I would like you to knock out utilizing those graphing calculators, of course, because you're not going to be calculating binomials and geometric by hand. Furthermore, I am going to be assigning you a homework of sorts before I leave the building here today, just so you guys are aware. I am going to be assigning you some kind of a homework of sorts before I leave today. It will be via Google Stream, Google Classroom, so we'll figure that junk out. So you have your Chromebooks logged on. Make sure you have the calculators out as well on the Chromebooks, because that's what you will need to get these problems done. But to get this thing really started, again, keep the Chromebooks open. I am also going to need those notebooks out and open. So you need the Chromebook in order to do the calculations. And you will need the Chromebook to utilize the PDF that I'm going to post. But I want to give a very brief set of notes, wrapping up what we have been doing. So let's see what we got here. Today is the 6th. I am going to be calling this Binom / Geomet. And you'll see why in a little bit. Binom / Geomet. Now, to kind of wrap up the idea of binomials are looking for a number of successes within a set number of trials. Binomials are looking for a number of successes within a set number of trials. That's what we've been doing with binomials. There are, I don't know, my parents are going to have 4 kids. That's the set number of trials. They're looking for a certain number of successes. Not that my sisters would be considered successes and that me not, but regardless, the certain number of trials are set. There is another calculation that we do in regards to geometric. It's quite similar. Geometrics are looking for a first success. Geometrics are typically looking for a first success. So I could reword. Okay. What is the probability my parents will finally get a boy on the fourth kid? Question mark. What is the probability that my parents will finally get a boy on the fourth kid? Now, the wording is a little strange, but I want you to recognize something. You have to be able to read the question and properly interpret what it's asking. In this scenario, what is the probability that my parents finally get a boy on the fourth kid? Is implying that they are looking to finally get that first success on the fourth kid. Meaning the first three kids, they did not get what they were looking for. And finally, that first success happens on the fourth child. The interpretation is that the question that I just wrote is a geometric problem. It's a geometric problem because you can interpret it as being a first success. So, what I do, and I'm going to ask you to do this as well, go to those calculators, and let's see how we can actually calculate this, and then I'm going to write down what you would have properly typed in, I should say. Now, in this case, again, I'm going to hit second vars. I'm going to go second vars. You could scroll all the way down, but instead of scrolling all the way down, you can just type up, and it goes straight to the geometrics. You have two geometric calculations. Once again, a PDF and a CDF. The PDF and the CDF mean a success exactly on that trial. The CDF is in reference to getting the first success on that trial sooner, which we'll talk about that. Right now, go to the PDF one, Geomet PDF. And if you hit enter, they only give you two options, P and X value. Well, in terms of getting a boy versus a girl, 0.5. One would argue, no, 0.51, 0.501. No. It's 50-50. Let's just leave it at that. Keep it simple. X value is the trial that you get the success on. So the question was, what is the probability that my parents will finally get that boy on the fourth kid? That's the fourth trial. Paste Geomet PDF with those two numbers in there. It spits out the answer. My parents, the chances that they would finally have me on the fourth kid was roughly a 6.25% chance. Here's what I would write down. If I'm going to do this calculation, I'd say Geomet PDF parentheses 0.5, comma 4. Now, in this instance, this is the probability of success, depending on whatever the problem is asking, of first success. So with geometrics, you really are only typing in, I'll move that up a little, you really are only typing in two numbers. The probability. Now, once again, just for the sake of argument, PD first success on the Xth trial. Move that up a bit. A PDF is getting the first success on exactly that trial. And a CDF is getting on the Xth trial or sooner. Remember, CDF adding everything up. So I'm going to do the calculation again in a few moments, and I'm going to do Geomet. I'm going to do CDF just to show you the difference between the two calculations. Oh, which, by the way, this one was 0.0625. So I'm going to flip back to my calculator very briefly. And I am going to do the same thing. Again, make sure you know where this stuff is on the calculator because you're going to be using this on the quizzes that I have for you in a little bit. I'm going to go down to Geomet CDF. CDF, the exact same things that you type in, the probability of success and the trial. Now, again, since it's a CDF, before I hit enter, actually, no, I'll hit enter here, and it won't do anything until I hit enter again. But basically, what this is going to calculate is the chances of getting it on the fourth trial, plus the chances of getting it on the third, plus the chances of getting it on the second, plus the chances of getting it on the first. And it's going to add all those numbers up. So, chances that you would get your first boy on the fourth kid or sooner is roughly 94%. But again, with the geometric, there's no set number of trials that could happen. There's no finite number of trials. I mean, you could have 10 kids. What was that show called? They kept changing it. The name of the show with all the kids? No. It was a reality show where the lady kept on pumping out kids. Something like that. It was nuts. They kept changing the title of the show every time she had a new kid. Yeah. I don't even know. It's messed up. The what? Wow. It is a lot of kids. What? It's a medical term. I could say, like, why is her arm still there? You know? It's a part of the body. And he used the proper name. Anyway. Back to this. So, here's what I'm going to do. I have a PDF that I'm going to be throwing in the classroom. I don't have a printout, which means you're going to have to access this PDF on the Google Classroom. Click. Post. There we go. So, now obviously it's a bit difficult to read this thing directly from the board. So I wanted you to have a copy on the computer or a physical copy, which in this case I didn't have one today. But I want to be so that we can talk about some of these problems today. So for those of you in live stream, I just posted this PDF into the Google Classroom so that you can access it and see it without having to squint at the board. But these problems are a combination of binomial and geometric problems. Again, with binomial, it's typically looking metric. They're really looking for the first success. What's going on with the first success? So, for example, number 1A. Anybody a lefty in here? Really? 3 of you? Wow. That's insane. Because, like, look, assume 18% of people are left-handed. You wouldn't expect the majority of people in this room to be left-handed. That's nuts. Anyway, get out. Now, assume 18% of people are left-handed. So for something like number 1, they are automatically going to assume that the probability of success in this case is 18% or 0.18. Now, yeah, they're selecting 9 people at random. Don't worry about that. Let's look at number 1A. Number 1A, the first lefty is the 5th person. That is a geometric problem. I know there are 9 people. The 9 people don't matter right now. The first lefty is the 5th person. If the problem is implying that you're looking for a first success, it is a geometric problem. Versus something like number 1, part D. So there's A, and there's D, Have you do this in a few minutes. I'm basically identifying the problems that I want you to complete. But number 1D, there are exactly 4 lefties in the group. Now keep in mind the 9 people are the group. Number 1D is a binomial problem. Successes that they are looking for within that group of 9. And then there's part E, which I would also like you to complete. I'm not going to give too much away on that just yet because I'm going to give you a few minutes to try it. And then finally, I'm going to have you do part F, but not the standard deviation part. I don't care about that. But I would like you to do part F because there is an additional formula that I'm going to have you write down in a little bit, but I want to see what you do first. So take the next few minutes. You have your graphing calculator on the computer, which obviously you're going to have to use. And I would like you to knock out number 1, A, D, E, F, but not the standard deviation part. Don't worry about that. Take a few minutes. Let's go. Good question. Good question. Answers are definite, but here's the thing. If I'm going to make a correction, I need to know what you calculated. So, for example, when I wrote down Geomet PDF, me being the first boy or whatever, in my notes, that's what I would like written down. Good question. Can you all hear my computer making that noise? No? Sounds like a jet engine. That can't be good. Okay. Let me just point a couple things out about. First of all, I'm going to be writing these into my notes just so I have a concrete copy of them just in case. But this is the lefties example. Now, P is going to be equal to 0.18. There's an 18% chance of getting a lefty. Now, I wrote N equals 9. N is the set number of trials that they would have in the group of people. If this were a geometric problem, N is not something you would have to type in. You would only use 9 if this were a binomial problem. For something like part A, as we mentioned, part A is definitely a geometric problem because they're looking for the first lefty on the fifth person. Flip that back. The first lefty on the fifth person. Now, since it's the first lefty on the fifth person, they don't say the words, but I am going to assume it's exactly that trial and nothing sooner. This is a Geomet PDF problem with 0.18, 5. That's what number 1 part A is all about. It's a Geomet problem because you're looking for a first success. It's a PDF because you're looking for exactly that trial. And those are the proper numbers you would type in. So I'm looking at second PDF 0.18, 5. Should be approximately 0.081 or 8.1%. And a lot of it comes down to the wording, and you're going to have practice on this on the quizzes that I have for you very shortly. Nope, wrong one. Boom. Part D. 4 lefties in the group. This is, as we talked about, a binomial problem. This is a binom. It is a PDF because you're looking for exactly that many successes. PDF. Now, in terms of what you type in, what's great is that you guys have that interface. You guys have that the interface on your graphing calculators, which show you, oh yeah, these are the numbers I would be typing in. 9 being the number of trials, 0.18 being the probability of success, 4 being the number of successes that I need. If I go back to the calculator here, second bars, I'm PDF because I'm getting exactly that many successes. There are 9 trials, 18% chance of success, exactly that many successes. The answer should be approximately 0.049. Again, a lot of these problems are going to come down to proper interpretation. We have to be able to interpret what the question is asking, and then based on that, pick the correct function in the calculator to use. Part E. There are no more than 3 lefties in the group. That's part E. Okay. Now I ask you, no more than 3. Is there a way that you could restate that instead of using the phrase no more than? Now that's the key. That's the key. 3 or less. No more than 3. Because it's 3 or less, I can definitely just use the CDF function, because the CDF function will give me that many successes or less. Absolutely. I can't change that about the CDF function. That's just what it does. Now I'm going to change this up in a little bit, but you'll see. If I do no more than 3 in the group out of 9, this is a binom CDF because it's cumulative. 9 trials, 18% chance, 3 or less. And then what it will do is it will calculate exactly 3, exactly 2, exactly, which is nice. Second vars, binom CDF, 9.18, 3. I got the CDF, meaning it'll do 3 or less. 0.938. 0.938. Question. What if I asked at least 4? What if I wanted at least 4 lefties? Say again? No, I wouldn't. What do you mean? Yes. Oh, 1 minus. Yes. Here's the thing. You could have 0, 1, 6, 7, 8, or 9 lefties in that group. Calculated that, meaning 3 or less. There is a 93.8% chance that you would get 3 or less lefties. But if I changed it up, and then I said at least 4, meaning 4 or more, as you just said, if I just did 1 minus 0.938, then at least 4 should give me what? 6.2%. Because that would be the complement. Just one of those things. The CDF function in the calculator will not do or less. It won't, unfortunately. It won't. Or I'm sorry, it won't do or more. You know the complement thing I was talking about. It will only do or less. Only do or less. It will not do or more. And then finally, I had you do F, which I didn't give you the formula for this. But I ask you guys, if there are 9 people, how many lefties would you expect? Huh? 0. Here, write this down. Hold on. Expected number of successes in a binomial is n times of successes in a binomial is n times p, meaning the number of trials times the probability of success. So for part F, it would be 9 times 0.18, which would give you approximately 1.62. Now, obviously, you can't have a fraction of a person. So you would say, you could either say on average about 1.62 people or something along those lines. That would be fine. That would be sufficient. You could also say between 1 and 2 people. Okay. I want to try quizzes. Now, the quizzes is going to be based on everything that we've been doing for the past several class periods. Originally, I introduced the idea of binomials right before break, and then we picked it up a little bit more on Monday, trying to review that thing the whole class period, and we just spent the last half hour reviewing this stuff as well. I want to not having that calculator open, having those notes open if need. But let's see what we can do with this. For those of you that are online, please join us as we go through this quizzes. There you are. Start a live quiz. Classic. Quiz.com. For those of you in the chat, of course, you can't see it. I'm typing in code into the chat, but for the sake of argument, I am also going to write 032020. But like I said, I've typed it into the chat as well, so you can join that. But I would like to try and knock out this practice quizzes in regards to geometric and binomial problems. It will take a little bit of reading. It will take a little bit of reading. But you should some key phrases. And like I said, this is just practice. Right now, this is just practice. We will eventually have to take an assessment, but that is not this day. It makes me sad. Where are the rest of my people joining the quizzes? Oop, I just heard another one. There he is. Chapow. There's another one. Did you click the thing? All right, here's what I'm going to do. You can still join even after I start it. I am going to start it because I want to get people going on this. But the code is at the top. It'll be top in white as well, but you'll see. Okay, here we go. Start. Okay, the bell's gonna ring in like 15 or so seconds. So here's what I'm gonna do. This is what I was planning on doing. I am gonna make a video reviewing these questions, and I will make that available to you, along with the thing that I'm going to assign you. So pay attention to Google Classroom, and we'll see you next time.